Girls, logarithm is the opposite of exponential. Girls? This is exponential form. We've done this last year. We had one lesson on it. Okay? So if you raise something to the power, this is called exponential form. All right? But if you, from here, if you want to make the power the subject, then the opposite of exponential form is called logarithm form. And what logarithm form does is it makes the power the subject. Okay? So in exponential form, you're raising it to a power. Logarithm, you're making the power the subject. Okay? So as a rule, girls, if y equals to a to the power of x, then x is equal to log ay. Okay? You've got to be able to rearrange it. It's like solving an equation. The way I like to think of it is, girls, from here, if you want to change it in log form, the way I like to think is you're digging this a underneath the y. So you have the a at the bottom and the y that moves just up to the top, if that makes sense. So when you add a log on, you're digging it under and then you're just putting those two numbers underneath and then up. Do you have a question? Yep. So this is called a base. Okay, it's log with a base of a. I don't know what that number's called, but there's no specific name that I can recall, but it's just a number. It's not raised to a power. This is just like a number. It's not like 2 to the power of 8. Don't read it like that. It's base of 2, log with a base of 2, and then 8. Okay, it's not 2 to the power of 8. That's not what it is. Okay, so girls, using this theory, I'm going to go through a couple of questions from the exercise. So in your exercise, they want you to evaluate this. So what's the actual value of this? So in order to do that, girls, the first thing you do, girls, you ready? You always make it equal to x, okay? X is what we're trying to find. That's your first step. Now, second step, put this back into exponential form. So the way I like to do it is, girls, get the base, dig it underneath. Okay, so that means 16, that number is equal to 2 to the power of x. That's how you do it. Okay? By trial and error, girls, you'll find that the answer is 4. Okay, 2 to the power of 4. Yeah? If you put in your calculator 2 to the power of 4, that is equal to 16. Okay? So that's your answer. What's the value of log 216? 4. Okay? Let's apply the same thing here. Make that equal to x, get the base number, raise it to the power. So that means 3 is equal to 3 to the power of x. And what power does that need to be? 1. So that's your answer. Okay? Which comes to the next theory. Girls, what's a to the power of 1? A. If I want to write this back into log form, yeah, log AA. Remember how you get the number and then you dig it under and you got log AA? So that's your next rule. If you have the base and that's the same as the number, it's equal to 1 like we saw here. Okay? So same thing here. Without having to do that, as soon as you spot 2 of the same numbers in a log, it's just equal to 1. Okay? Next theory. Anything to the power of 0 is 1. Let's write this down as log. So if I write this down as a log, 0 is equal to, if I dig this under, what am I writing? Log what? Log A1. So my point is, if you have on top of the base, if the number is 1, it's equal to 0. So here, you've got 1. So what does this equal to? 0. Okay? If you don't remember this rule, that's fine. You can go through this process like I did in the beginning, but it just speeds up the exercise a bit. Okay? Did you want me to show you the long way?
No, it's okay.
Okay. When it comes to this question, this technically means 3 times log 2a. Okay? You don't want to get the 3 involved right now with this calculation. You want to just figure out what that is first. So I'll just do it in purple. So let's just figure out what that is. And if I want to find out what that value is, what did I make it equal to? You make it equal to x first, and then put it into exponential form. So dig that under. So 80 is equal to 2 to the power of x. So x is equal to? Yeah. So that means this part is 3. So the answer to this whole question is then?
9.
Yeah, 3 times 3, which is 9. So that's how you do the question, okay? All right, final rule. Girls, if you have a base, and a number actually raised to a power. So this is raised to the power, okay? Think of this as just x moving down, so that's your answer. So if you have a base and a number, but then you have that number also raised to a power, it's just x. Let me explain what that means in this actual question. Because when it comes to a question like this, we have a base of 5 and we have 1 over 25. Because the first thing you want to write is actually write this down as a power of 5. What's 1 over 25 in terms of power? Isn't it 5 to the power of minus 2? Yeah? See how we've got 1, 2, 3 now? Okay? So if you've got 3 terms, that top power is your answer. So think of it as just moving down. So it's just minus 2. The answer is just minus 2. And the reason why that log 5 is gone, so technically this is this. Yeah? But what's the same number? 1. So this is really you just doing minus 2 times 1, which is just minus 2. Okay? So that's your concept. Let's apply the same thing here, girls. As soon as you sixes, write this down as a power. So we've got log 6. Now this one's a bit tricky, so let's break this apart. This is the same thing as doing 6 times root 6. Yeah. This is 6, 1 times... Yeah? So what do I do with the powers? Yeah, 1 plus a half is 3 over 2. Okay? So answer is just 3 over 2. That's right. You're just bringing that power down. Okay? Now, this is a tricky question. Pay attention. And it's the second question in your exercise. All right. So with this question, they want you to evaluate this. Notice I have 7 to the power of a log. Okay? So what you need to do, girls, is actually, girls, let's just focus on what that value is. Let's find out what that value is. So let's find out what the value of log 7/4 is by making it equal to x as usual. And let's change that back into exponential form. If I change it back into exponential form, what is it? Yeah, so 4 is equal to 7 to the power of x, isn't it? Now, here's the tricky part. We just labeled this whole thing to be x. Yeah, right now I have x here. If I replace this x back in here, don't I just go back to that? Check this out. The 4 stays the same because I'm going to replace this x with this because I just made it equal to x.
Oh, okay.
So, girls, here it is.
That looks so messy. Oh.
I don't know if you guys can see this. Does that make sense?
Oh, okay.
Yeah, this x is that because x is that. So, girls, what's the answer to this whole thing? 4. It's just 4. That's right. So this is equal to 4. So really, the quickest way is that basically, if you have the base with the same base of log, the answer is just that. Okay? But the reason is because of that. Does that make sense? Tricky. All right, last two, nothing fancy. They just want you to learn how to use a calculator. If they want you to evaluate log 10 that, it's just you typing in the calculator log 1200. When you type in log, that automatically assumes the base is 10. Okay? And you'll get some decimal place. Can you, someone actually do it for me, just quickly?
3.79.
Okay, so 3.8. Okay? However, girls, if the base is E, in your calculator, it's the same thing as typing ln 25. That's an L. Okay, if someone can do that for me. Decimal place?
3.2.
3.2. Okay, that's all it is.